Hello, Konstantin here. So we've just released an update to Sail, and I'm excited to show you around the new profiling tools built into the new version. So here I have a sample site I provisioned a few minutes ago with Sail. I installed about 20 plugins from the popular section on WordPress.org, and let's see how that'll affect our performance. So the easiest way to launch a profile with Sail is to run sail profile and give it a URL. So in our case, let's try on the homepage, saildemo.com. So I'll make the profiling request, it'll download all the profiling data, and it'll open the Sail profile browser. So here in the browser, we can see that the total wall time for this particular request was 1.1 million microseconds. So that's about 1.1 seconds, which is a lot. The peak memory is 35 megabytes. Which is also quite a lot compared to a vanilla WordPress install, which consumes around 6 to 8 megabytes. We got the URL, we got the method, we got 417,000 function calls, 120 database queries, and 1 external HTTP request. And here's our list of functions. So let's go through these columns one by one. The count is the number of times a specific function was called. The inclusive wall time is the amount of time taken inside that function, but also all of its children. The exclusive wall time is the time taken inside the function less the time in its children. And similar with inclusive and exclusive memory. So inclusive memory is the memory consumed inside the function and all of its children. And then exclusive memory is the memory consumed inside of the function, but not its children. So if you see a negative here, it means that the function after returning from the children is actually freeing up some memory. This is why it's negative. You can use the arrow keys here to change the sort columns. Usually sorting by exclusive wall time will give you a very good hint at what is really wrong when it comes to performance. Inclusive wall time is useful when you want to dig in step by step, basically into what's happening starting from the very top. So here, for example, you can see that the inclusive wall time is 1.1 seconds, but it's a lot actually. 300 milliseconds was spent inside do action init. So this is the WordPress init action. These three are basically the same. One calls the other, and then that calls the next. But if you want to look into what's actually happening on init, you would step into WP hook, apply filters in it. So I'll press enter here, and then this is the screen where I can view I'm inspecting a specific function, and I can view the parents and all the children of the function with their metrics. So here, for example, on apply filters init, we have all these children that are being executed on init, and they're sorted by inclusive wall time, which is what we generally want. So here, as you can see, SPL autoload has been called 870 times with a total of 128 milliseconds. So quite a lot. I mean, we can try and see what what is actually happening in SPL autoload call. We shouldn't be looking at the parent functions here, but probably the children. So I'll scroll down to the children. Here are the child functions, and here's composer autoload is consuming 74 milliseconds. Then automatic's jetpack autoloader is consuming almost 20 milliseconds, and Elementor is consuming almost 16 milliseconds. And then the rest are a little bit better. I guess they have less files and less classes and things like that. But this will give you a general overview of what's consuming what on the init action in particular. If I want to go back, I press the backspace key, and if I want to go to the main screen, I'll just press the escape key. Another example, WP head, as you can see, it's 238 milliseconds in WP head. So this is where our scripts and styles are loaded. If I dig in, I'll see that the WP enqueue scripts function is taking, this is weird, this is taking 15 milliseconds. So might need to look into that as well. But this is the biggest offender of 203 milliseconds. WP-enqueue scripts. So let's see what's going on there. WP-enqueue scripts is calling the WP-enqueue scripts action. That is calling the WP hook do action with WP-enqueue scripts. That's calling apply filters with WP-enqueue scripts. So we keep digging in, and here we are. So Elementor front-end register styles. One function call, 176 milliseconds, the inclusive wall time. So all of the stuff responsible for WP head is mostly this. It's 176 milliseconds just in this function. So this is probably a pretty bad for performance in general. So these are actions and filters. You'll also see things like database queries. They will be tagged with a specific query. There we are, MySQL query. So I can actually try and navigate to WPDB do query. So this will contain all my queries that go through WordPress. And here I can sort by, it doesn't really matter whether it's inclusive or exclusive, because they don't really have any children function. And these are the queries. So 8 milliseconds, select option value from options, where option name is Elementor disable color schemes. Limit 1, 8 milliseconds for this. 7 milliseconds for selecting post meta of a specific post. And I mean, the database here is not too bad. So it's 47 milliseconds in total. So it's not, some of these can probably be removed from here. Like this thing, for example, WooCommerce, like all of these can probably be grouped into one single call. Like all of these seem to be from WooCommerce. Oh, this is from BuddyPress. This is from BuddyPress. These are WooCommerce, WP Lang WordFans. Yeah, all of these can easily be grouped into a single call to MySQL to just fetch all of these options at once and cache them into the object cache instead of, it's not a lot, but it adds up. It certainly adds up. You'll also notice that, I don't know if there's an example here for closure functions. If not, it's fine. We can run a quick test later. But what we do have here is a curl exec. So curl exec will also be tagged with the URL of where the remote request went. So here, as you can see, there's one HTTP query, one HTTP request for this specific request that I'm profiling, and curl exec will just show you, where it's going. So you can see that, okay, this is WordPress invoking the WordPress cron. You'll generally see them in like request or request transport curl request. You will see curl exec here listed. If it's called multiple times, you'll see where all the requests are going and then how much time they're taking. For closures, can probably do something simple. So WP content, let's do an MU plugin, test.php, and let's just add action init. Let's write a closure function, and let's have it, I don't know, sleep 1 second. And yeah, these closure functions are usually difficult to debug in profile because they don't have like a name or anything, and usually in profilers they will just show up. So deploy, they'll just show up as a closure function. But with the Sail profile browser, we tag these functions with the file name of where the closure function was executed from, as well as the line number. So successfully deploy. I'm going to execute the profile again on the front page. Here's the sleep, right? But the sleep, we can find out where it came from. So it came from here's the parent function. It's a closure. So it's in WP content, MU plugins, test line number 2. And if I open this up, I can see that it's being hooked on Init. I can see the children that are taking up all of the time, and so on. So yeah, these are closure functions. And yeah, that's pretty much it for the browser. So a few other things. When you run a profile, you will see that the profile has been saved to .profiles and the file name. So these will exist locally on in the working copy of your Sail project. So if you don't want to run a new profile, but if you just want to open it, you can do Sail profile and then the path to this profile. So in my case, it's .profiles and then this file name. And I can just open it. It doesn't even have to be like in a Sail project. It's just any JSON file that looks like a profile generated by Sail. It'll open it without even needing to provision a server. So you can easily share profiles with your friends or coworkers and have them use Sail to open and navigate these profiles. Let's see what else we have here. We have Sail. Oh, we have the curl wrapper. This is really interesting. So if you wanted to profile a logged in request, you would need to specify like a bunch of headers for logged in, the logged in cookies and things like that. So basically all of this, you would need to specify it in a curl request, and you can do that, especially with tools like Chrome or Chromium, where you can right-click any request from the network tab in the developer tools, and you can copy it as curl. So here's what I copied from Chrome. Here are all the headers, basically everything. So if I execute this in my terminal, it'll just give me the same, the HTML output. Now, if I wanted to profile this, all I need to do is add Sail profile here in front of curl. And this is going to invoke curl. It's basically just a proxy to curl with all of those things. So all of these things are just passed directly to curl, and then Sail just adds the special profiling key to make sure that the profile is generated, and then reads it back, downloads it from the production server and opens it in the browser. So this is then the logged in request. And similar to this, we can do a WP admin request. Let's go to the dashboard. And let's copy this WP admin request from here. Copy as curl. And then run Sail profile and paste the entire curl request. There it is, 2.5 seconds. I mean, one of those seconds is the sleep thing that I wrote. So yeah, that's how you can execute profiling requests with curl. Another option is a query string. So if you run Sail profile key, you will get a secret profiling key, which you can then use as part of any request on your site. For example, let's go and visit the home page again. And if I append this key as Sail_profile, all caps, and run it like this, it'll generate a profile request. However, in order for me to open this request in the profile browser, I have to actually go and inspect the headers here and find the Sail profile header, which will tell me the file name of the profile that has been generated. And then this file name, in order to get it locally on in my local working copy, I have to Sail profile download and the path to that profile. And it's going to save it to profiles locally here in my working copy. So now that I've downloaded, I can open it. Sail profile and the file name. It's a little bit trickier, but sometimes sometimes this is how you would want to profile request, especially if a specific user, for example, is having a very slow page load, but you cannot reproduce it on your machine, on your computer. Then you can just maybe share the profile key with them and ask them to run the same request, but just append it to the query string. It also works as a header. So if you do xSale profile header, just like this, with the same key, it'll perform a profiling request every time it encounters that. So you can use a Chromium plugin like mod header, Chrome mod header. So it's a Chrome extension which basically allows you to specify custom headers for each site. So you can specify an xSale profile header, and every request that you're going to make to your site from the browser with the extension active is going to generate a profile. And then you can find them in the profiles directory on the server. Now do know that if you do generate these profiles but don't download them from your production server, they will stay there indefinitely. And each one of them, depending on the complexity, we can check right here, so sale SSH, depending on the complexity of your app, they can consume quite a lot of disk space. Well, I don't have any profiles here because I download them all, but if I generate one right now, it's right here. So it's 2 megabytes for this particular profile. So you have to be careful and either download every single profile that you generate and turn off the mod header extension when you're done profiling, or you can do sale profile clean to delete all of the profiles saved in production and the profiles saved in your local working copy as well. So you can use that when you're done profiling. So yeah, that's about it for profiling. And if you have any questions or comments, feel free to leave some feedback on YouTube or on Twitter or on GitHub. If you are new to Sail, it is an open source CLI tool to deploy and manage WordPress applications on DigitalOcean. You can get it for free on sailed.io. And the documentation there will have all the profile stuff and everything else that you might need. Cheers, thanks for watching.